work out examples of the binomial and the Poisson distributions, both of which are discrete distributions. Now, binomial distribution, as we know, is a distribution where you have only two outcomes, either one is a success and one is a failure. So wherever you get data of this type, a binomial distribution is ideal. So the probability then mass function of the binomial distribution is n factorial into n minus x factorial into x factorial into p raised to the power of x into q raised to the power of n minus x, where p is the probability of success and q is the probability of failure. X is the event that we are trying to measure the probability for. So now let's take an example. Let's take an example. A distributor wants to know how many films he must distribute if the probability of success of a movie is released during the holiday season is 0.35. If 10 movies are released during the season, what is the probability that 3 movies will succeed? Now let us take an Excel sheet and work this out. So in this example, n number of trials is equal to 10. P, which is a probability of success, is equal to 0.35. Q, which is a probability of failure, is equal to 1 minus the probability of success. And X is the event that we are trying to measure. We want to measure what is the probability that 3 movies will succeed. Now we'll apply the formula, which is equal to fact n. In Excel it is called factorial n divided by factorial n minus x into factorial x multiplied by p raised to the power of x into q raised to the power of n minus x. The probability that 3 movies will succeed in this situation is 0.25. So which is a failure. Now let us see the entire range. So what is the probability that no movies will succeed? Probability that 1 movie will succeed. Probability that 2 movies will succeed. 3 movies, 4 movies, 6 movies, 7 movies, 8 movies, 9 movies. And probability that all the movies will succeed given this probability. So we'll apply the formula. Fact n, so we only need to fix it, divided by fact n, and fix it, minus x into fact x, which x in this case is x, multiplied by p, I need to fix it, raised to the power of x into q, which also I need to fix, raised to the power of x, n minus x. I'll fix it, minus x. So please carefully note the formula. So it's factorial n divided by factorial n minus x into factorial x into p raised to the power of x, q raised to the power of n minus x. So I fill it. And now since it's Excel, I can just drag it because this is the x. The x is varying from time to time. Right? Okay. So you can see that the probability of no success is very low. Probably that one movie only will succeed is 0.07. Probably that two movies will succeed is 0.17. The probability that three movies will succeed is 0.25. And the probability of four movies succeeding is 0.23. Probably that five movies will succeed is 0.15. So you can see that 0.25 is here. Three movies succeeding is most likely, four movies little less. Probably that at least four. Now this is called the probability density function. So if I were to plot this, for different values of x here. I'll get the probability density function. This is called the probability density function. So it gives you the probabilities at each level. This is called the probability density function. This is called the probability density function. So this is called the probability density function. Now I can accumulate this and get a cumulative. This is PDF, probability density function, because it gives us a probability. Cumulative probability density function is equal to this one. And this is a cumulative probability density where I accumulated the last value should be 1. And if I plot this gives me the cumulative probability. Insert. Here I can use the line. I get the cumulative probability density function, which is nothing but the cumulative of the same thing. So in every distribution, you get it in continuous distributions. You get it by summation. In discrete distributions, you get it by adding it. So I know the probability that it will be 0 is 1. Probably it will be less than 1 is 0.8. The probability it will be less than 2 is 0.25. The probability that up to 3 movies will succeed is 0.5. Right? And the probability that less than 4 movies will succeed is 0.475. And probability that more than 5, the probability that more than 4 movies will succeed will be 1 minus this, which is equal to roughly 0.25. The probability that more than 2 movies will succeed, more than 4 movies will succeed is just cumulative probability is 0.25. Now we will move into the Poisson distribution. Take an example. Poisson distribution is a distribution of rare events where the mean and the variance is the same. The density, the probability mass function of the Poisson distribution is given as e raised to the power of minus lambda raised to the power of x, and divided by x factorial, where lambda is equal to the mean, okay, and x is the event that we are trying to predict. Now here's an example. Since opening 10 years ago, Bangalore bypass has seen that there were no less than 4 separate accidents during the hours of the day there were no less than Bangalore has seen since the opening of the 10 years since opening 10 years ago, Bangalore bypass has seen 10 years by seen there was no less than 4 separate accidents during the hours of darkness. So there were 4 accidents, and it was a full moon night. So on a full moon night, there were always about 4 accidents. Was it, we wonder, the full moon madness? Or was it just one of those statistical quirks that happen from time to time? So I'm a statistician, and so I cannot tell you what the chances are of these 4 accidents in the evening, but I reckon that it is a statistical probability. So how would you decide whether 4 accidents at a night are reasonably likely or not? So to answer this question, we need data, and this data has been provided, that the number of accidents at night, during the day, are 0 accidents 395, 1 accident 295, 235, 2 accidents happened on 73 days, 3 accidents happened on 17 days, and more than 3 accidents didn't happen at all. So we take this data, and now we'll apply the formula of a Poisson distribution with this data. So this is the data. So the first thing that we have to do is we have to calculate the value of lambda, which is nothing but the mean. So to get the mean, it is frequency into the value divided by the frequency. So I can do it in Excel by just using the command sum product. Sum product. Sorry. Sum product of the x's by the frequency. So this is 0 here, I'm not counting that. I close the bracket and divided by the sum of the frequencies. So the lambda is 6. The value of x that we want to find out is 4. And now we're going to calculate the probability using the formula. So the probability of x is going to be calculated using the Poisson distribution. So the Poisson distribution, it is the formula is E, which is in Excel it is EXP raised to the power of minus mean lambda into lambda raised to the power of x divided by factorial x. Factorial x. So I'll just check the formula once more. By x factorial. So there's a spelling mistake, and I'm sorry. The probability that there will be 4 accidents is 0.02, which means that is a very remote possibility, and that was only a quirk of the full moon, and therefore this settles the issue regarding whether 4 accidents would happen or not. So practice is very important for one to get familiarity with distributions, and one has to practice a lot of examples before he can finally get a hold on how to use distributions in real life.